Okay, so we say that everything in Unix is file. Okay, but files are of 7 different type. There are 7 types of files to distinguish between user data and devices and processes. Okay, number 1 is my plain ASCII files. These are denoted with the symbol as dash. Second type of files that we have is, these are called as my directory container, and these are denoted with a symbol as a small d. Third type of files, we call them as symbolic links or simply symlink. These are denoted by the symbol small l. Denoted by the symbol small b. These are my user data, programs, binaries, images, everything. Okay, these are my folders or directories, shortcuts, the storage devices that read, write in chunks. Fifth is my character special files, denoted by the symbol small c. The storage devices that read or write in bit by bit format. Okay, sixth type of file is called up as my named pipes. A small n or a small p oblique capital P oblique small p. Based on the Linux or Unix operating system, any of these symbols would be used, either by small n or by small p or by capital P or by capital N. These are my inter process communication. When I need to communicate two processes with each other. And the seventh type of file is called up as my Unix sockets, denoted by symbol small s. They are also for inter-process communication on socket based applications. Okay. So everything in Unix is file, but files are of 7 different types. So the advantage that we get here. So what advantage we are getting? See here, if you check, my devices are identified either as my block device or as my character device. Block device means any device, any hardware component which is taking input and sending output in a chunk of data, bytes of data, where it is sending not just a bit, but it is sending amount of data there. We refer them as all my block devices. So examples of my block device: CD, DVD, hard disk, all of them are what? These are my block special devices. Character specials, like say my modem, keyboard, printers, all of them are my block special devices, sorry, character special devices, where you don't send in a whole instruction set in one shot, you send it bit by bit. So where the communication is happening in a bit by bit fashion, those are all referred up as my character special devices. So what advantage my Unix system is getting by these? The Unix system is getting advantage as it now need not to separately bring in another application called as my drivers. Like in case, if in a Windows machine I need to access my printer, what is the process there? The first thing is I need to have an application installed on my system called as my printer driver. And every time when I send in a print command, what happens on my Windows box is my UI, that is the print application, whatever application I'm using, let's say this notepad itself, I need to send this to my printer. So first, this application will talk to the kernel. Kernel will invoke the print dialog, where I will say I want 1 copy, 2 copy, 3 copy, number of copies, and whether I want to have a collated copy or a non-collation copy. So we give that instruction, but for this print dialog to be able to send the command to a particular printer, what it requires is, it requires a separate application to be called, which is nothing else but my printer driver. If I don't have that printer driver, I cannot print to that. So first is you made a call to the application. Application in turn invoked the kernel. Kernel in turn made a call to the printer driver. Printer driver in turn took the control of the hardware. Then you got the print. Again, response whether the page was successfully printed or not, it comes to the printer driver. Printer driver gives it back to the kernel. Kernel gives it back to the application. Printed. Printing done. The difference that happens in my Linux or Unix world is all my drivers are loaded at time of my OS boot up. Here in Unix and Linux, what we call it? We call them as my device modules. We refer them as our modules. Modules start or modules initiate with your application itself, with your OS itself. The moment my OS came into picture, all the modules which are required by my OS, they also came into picture. So now the point that happens is, there is no separate calling and callable stack coming into picture. Now I need not to separately make a call to the printer driver because it is already in the system memory. When my system started, together with my OS, the driver also came in here. Or you can call it the print module also came into here. So now print module is already in my system memory. It need not to be separately called. I need not to make a separate call to the printer driver for seeking control of my printer. So it's already into the system memory, and because it is already into system memory, this time that goes into calling and getting a response back is eliminated, thus making my system go faster. That is the reason same machine, same hardware with a Linux or Unix operating system and a Windows operating system is always faster as compared to the Windows box. Reason being, because here all my device drivers are loaded, or you can call they are already into the system memory. Second thing, there is no separate way, there is no separate requirement of making a call, because in Windows what happens is you get a .drv, .vxd, .inf files for your driver initialization. Is it? For everything you need to have a .ini, .drv, .vxd sort of files, which are separate applications in themselves. Whereas in case of Unix, because everything is treated as a file, everything is a file. So as everything is a file, I need not to make a separate call to the device, because my device is also being managed the same way as I am managing my data. Is it? So because everything is managed in the same way, there is no separate invocation of an application. The application already resides with my system. That is clear? Okay. So everything is file in Unix, but files are of 7 different types. How can I view them? Is there any method by the help of which I can view all the different types of files? There is one directory which is your /dev, having registry of all the types of devices. When I want to get the details of any of my file, what I have to do is I have to just simply run my ls command with -l switch. So if you run your command ls-l /dev, you should be able to view details. Is there any change in the output that you got from the ls-l command and the ls command? Any change in the output? ls is a command to list the contents of given directory. Okay. So if I want to view the contents of a given directory, what we do is we simply run the ls command. There are many switches with the ls command. In Unix, to run a command, there is syntax that governs. cmd, that's my command, followed by hyphen options, followed by parameters or arguments. Okay, this is the general syntax to run any of my Unix commands, where parameters or arguments could be optional or could be mandatory. So anything whichever is written into your square brackets, this is an optional entity. Some commands have parameters, some commands don't have parameters. Some commands have options, some commands don't have any options. Like when you executed the command ls, shows contents of current directory. Okay. Whereas when I use the switches with my ls command, how to get the list of all the switches or list of all the options that I can have with it? Use it ls space minus minus help. ls space minus minus help to show a list of all options that can be used with ls. Just run it and see what you get as output. ls space minus minus help. Did we got some information on our screen? With options like say minus O, minus L, minus M, minus G, minus D, minus U, lot of options there. And with the description of the option written next to it, what each and every option is doing. Lavi, able to get? Okay. So here, this method you can use for any command. So if I know a command but I don't remember the options, or I want to find out if this command is having any options or parameters required, to find if a command is having options or parameters, just simply do what? Command name space hyphen hyphen help, do it. That could be any command. So like we have seen how many commands by now? Till now I have checked how many commands. We have worked on how many commands till now since morning? One is ls and what is the other command? Uname. Okay. So can you find out the options associated with uname command now? Can you check what all are the options with your uname command? I have given you only one, uname minus r. So can you tell me what more options are there with my uname command there? How we'll find out? Uname space minus minus help. Got it? Yes. So isn't it cool? We can easily find the information. Any command. It's not only for this command, any command. Meal vouchers. Yeah. Okay.
And your lunch is at Johari restaurant.
The Johari restaurant. Okay. Wait. Today we are only 4.
You only 4?
Yeah. Today we are only 4. From tomorrow we will be 9.
From tomorrow will be 9.
Yeah.
Okay.
So today I'll take only the 4.
Okay. Thank you.
Here is your lunch voucher.
Okay, thank you.
Lunch voucher. It will be in the Johari restaurant.
Or I think we
Outside.
the other side.
Yeah, the other side. This is vegetable or veg or non-veg?
Non-veg. No, this is vegetable.
This is vegetable.
These are sweet potato, right? Yeah, it's a vegetable, not
And the other one is a non-veg.
these are the. Yeah, these I'm seeing contain some meat.
Both of them are mix.
These are also some meat, I'm not sure. These are the. These I'm seeing as meat.
Yeah, these are right.
Yeah, you can check better.
You are the one you can find it easily.
Yeah.
If it is a meat or
Yeah, for us we do raw.
yeah.
We don't mix ready-made.
So for you it doesn't matter. Hmm. That's a meal voucher. Okay. So the same way, you can get listing about any command cell. So when we execute ls minus l, what we get is long listing details of files. So what we are getting here is a long listing. In Unix word, my files have a unique name. No two files can have a duplicate name. Name means duplicate ID. Every file has a unique ID, which we call up as the inode number or the inum, identification node IDs. Every process has a unique ID called as PID. Every user has a unique ID called up as UID. Every group has a unique ID called up as my GID. So GID, unique group ID, UID, unique user ID, PID, unique process ID, and inode, unique identification number of all the files. No two files have the same number there. So ls minus l, this gives me the details stored in those inodes. This shows me a 9 column output, where the first column is your 10 dashes. Followed by a plus or a dot symbol, followed by a digit there, followed by owner name, followed by group name, followed by file size in bytes, followed by last modified date and time, followed by file name. Total 9 columns. This is my column number 1, column number 2, column number 3, column number 4, 5, 6, 7, 8, and 9. These are the total 9 columns shown in the output of your ls minus l. Column 1, this shows me file type and permissions. So for managing my user file permissions, we will be using this column. We'll be playing with this column. So when we talk about in our session related to our security administration, in security administration, we will be playing with the values of these columns, file types and permissions. Only you cannot change the file type, rest every information can be modified. Every information can be modified. Okay. Only file type is something which is fixed. You cannot change the file type. Like I cannot convert a symbolic link into a directory. I cannot convert a directory into a socket. A socket cannot be converted into a named pipe. File types are fixed. That cannot be modified. Rest entire information what you are visualizing can be changed. Okay. So file types and permissions are in my first column. Column number 2 is hard link count, or by how many names you can refer this file. That's the entry in my column number 2. Okay. Column number 3 is name of the file owner. He is the file owner name. Name of the user who owns this file. Okay. Number 4. Members of this group have collaborative permissions on this file. Number 5, size of my file in bytes. Number 6, seven and 8. Last modified date and time stamp. When the file was last modified. And the 9th column, actual file name. So you can visualize that the column number 1 is having some 10 dashes into it. Is it? When you run the ls minus l command, the first column shows you some 10 dashes there. The first one is a dash followed by some RW dash, then RW dash, then R dash dash, something like that. So here the first dash is file type. One, two, three, four. They are like this with a plus symbol or a dot there. So let's talk in detail about all of them. The very first dash that we have, this is my file type. What type of file it is? A value of dash means it is a plain ASCII file. If the value in this column is a D, it means it's a directory container. If the value in this column is my small b, it means it's a block device. So when you will run the command ls minus l/dev, you will be able to find all the different types of files there. Sorry. Okay. The block which I have in my maroon color, these are the permissions of the file owner. Whatever values are coming up here, these are the permissions which are available to the owner of the file. The owner of my file can do these operations with this file. Then common permissions for members of the group. So whichever user's name was given in the group column, in your column number 4, that user will have this set of permissions there. And finally, these are the permissions for everyone. In Unix world, we call it up as small u user permissions, small g group permissions, and small o others permissions. And this plus is my access control list, presence or absence. If it is a plus, means the file is having access control list applied. If it is a dot, the file does not have access control list. So presence of a plus symbol shows that you have special permissions, you have some special set of privileges given to custom users. Access control list. The file is having a ACL, the file does not have a ACL. Okay, so on this channel you can find the basic commands discussion and all. I'll show you. Let's say my YouTube channel, ATS Vivek Trivedi. Okay, and here I have added a series called as Linux from scratch. Yes, wherein you have your basic commands, part 1, part 2, archiving, compression, package management, user quota and disk management. 6 videos. So this is for your future reference, if in case you want to refer in there. I'll just take in a quick recap of the basic commands of Unix, which are generally used in our as a admin, which I should know for my day-to-day operations. As a developer or as a scripting engine guy, I may know a lot of commands, but I'll just take in a quick recap of those commands which as a system admin I should have under my belt. Okay?
Yeah.
So starting with the basic command, number 1, ls list contents of a directory. Okay. Number 2, cat list contents of a file, or other words you can say view file contents. Only ASCII files. Images and videos you cannot view using the cat command,
Yeah.
because those are binary files. Okay, so the files like say my C program, Python program, Bash script, or my Java programs and all that I can visualize by using my cat command. Any file contents my configuration scripts that we have in our Unix. All those configuration scripts you can view by using the cat command. Okay. Third, touch. If a file exists, modify the time stamp, else create a new file of 0 bytes. Okay, if a file exists and you have ownership, modify the timestamp of the file, else create a new file of 0 bytes. That's the job of touch command. Fourth, mkdir create a directory or folder. RMDIR, remove a directory provided it is empty. If the directory is not empty, you cannot delete it by using the RMDIR command. Okay. CP, copy file to same location, same or different location. 7 MV, move or rename a file or directory. Head, view, first 10 lines of a file, tail, view, last or specific from bottom of the file. Grep, to search for a specific pattern in file. Cut, to filter file on columns. In other words, we can call it as a row filter and filter file and column filter. Sed as a stream editor or advanced non-interactive row filter. Okay. word count. Gzip, gunzip, and 16 bzip, bzip2, bunzip2, gzip and bzip both for creating in compress. Then 17th is my tar, create a file archive. Because using gzip or bzip you cannot directly compress a directory. So directory has to be firstly archived and then compressed. Files you can directly zip. I can zip a file directly, but I cannot zip a directory. That is, I cannot compress a directory. So for compressing a directory, it has to be firstly archived and then compressed. Gzip and bzip is good when you are dealing with a single file. When you are dealing with multiple files, that is a whole container, you cannot compress the whole container using the gzip or bzip command. For compressing the whole container, the container needs to be firstly archived and then that archive can be compressed.
But I think archiving is also reducing the size. Or is just
It's just enabling the archive bit.
combining the
It's just
multiple
enabling the
files.
archive bit.
Okay.
Because when you take a backup, the file needs to have an archive bit enabled. If a file is not having archive bit enabled, you cannot take it as a part of a backup. So tar is also a backup utility. Create a file archive, or simply we call it up as a tape archive or tape backup. Tar actually is my tape archive. Created an archive for my tapes, for the tape format, the DLTs and the ILTs tabs.
But not all tape drives usually have that format with that.
All of them have.
All of them.
All of them. Whatever is supported on Unix have that. All those tape drives which are supported on Unix, they have the tape archive.
What about a different application? Can it save using a different format?
Yes, you can. How can I get to know about all these commands? One option is You can get the quick help using the same method. Just type the command name space hyphen hyphen help. That is a quick reference. I have given you a lot of command names here, and you want to get the details of any one of them. You have to just do what? Type this command space hyphen hyphen help. It's a quick reference on your screen. You want to get the detailed help. Most important command: when you don't know anything, ask man. Simply, you don't know anything, ask man. And how to ask man? Man followed by the command. Let's say I don't know how to use tar. So man tar, hit enter. Just do it. You have to just type only one, press Q. Q to quit. Okay, so I'll give you half an hour. What you have been doing since your childhood? When you didn't know anything, what you used to do? Ask your old man. Is it or not?
Yes.
That's what we do. Even till today, when we don't know anything, what we do? Where do we go to? We go to our old man, to my dad. So when you don't know anything, ask man. You don't know the command to use, what you have to do is, you have to just simply ask man. And you have to ask him with a specific method. Okay? And what that method is? So if I don't know what the command is, what I'll do is, I will just simply do a query to him. And how I'm going to query him? Man hyphen K, keyword. Man hyphen K, K stands for keyword. What I don't know? The partitions. How to define partitions? So I want to get the commands related to the partition keyword. Man hyphen K partition. Run it on your systems. Man space hyphen K partition, and see what you get as output. If there is any command on your system that uses partition word in its description, the command will be listed out for you in a 3-column format as command followed by command section and followed by description of the command. Is it? Are we getting somewhat similar type of output on our screen? Man space minus K followed by the keyword. So in our case, what we want to do? We want to do the operation of partitioning. So any command that uses partition as a keyword in the description, that will be listed for me. Okay? So what all commands do we got in our listing? We got the parted, okay. We got something called as kpartx, gparted, or fdisk. Any such commands coming in our listing?
Yeah.
Okay. So all such commands which you are getting in the listing, these all are used for your partition management.
What you say is that the one in between before the
Section.
description or section.
Section. Okay. So now let's say if in case I got 2 fdisk utilities, I got 2 outputs for fdisk. Any command having two entries there on your screen? When you executed this man hyphen K, what we just did is to find the help. Man hyphen K followed by the keyword to be searched. So like here in our example, we are checking for man hyphen K partition. So it should have given me listing like say F disk, then after that in bracket written as 1, then followed by create DOS partition table, something like that. Okay. So how I'm going to refer this? How I'm going to refer to this particular manual? I have to see if in case any command is coming with section 1, that is the default section. You don't have to explicitly call a section there. But if a command comes up twice, then I need to refer the section there. Okay. So how I will be referring this man page? I will be now making a call as man minus s followed by whatever value you got in the second column. I'll type it as 1 and then the command name. So what this will do is, this will show me the manual of fdisk command for section 1. So man hyphen K followed by the keyword gives me a listing of all the commands that uses this keyword. Then to refer to a specific section, what we do is we refer man hyphen s followed by the section number. So if in case any command is coming up with a section as a 3p, 1d, then you have to refer it in that format. Okay.